No. Hey everybody, welcome to the February 2023 event for the Atlanta Kubernetes Meetup. You may notice that it's a little lonely here. It's just myself here running the event right now. My esteemed co-host Joe's running a little bit behind, so we're gonna have to skip the news segment here shortly, and we'll be jumping right in with our presenter in just a moment. As always, we like to start with a call for hiring in the community. If you or your team or your company are hiring for roles kind of in the Kubernetes cloud native space, post information in the chat, preferably a link to a role and contact information for somebody at the company that people can follow up with if they're interested. I will read those out and also make sure that they get put into the show notes. Get them posted quick so we don't have a news segment to run through while they're getting posted. And while you all are doing that, as I always like to say thank you to our sponsors. Calendly is providing this webinar link for us, the ability to kind of let us host everybody and do all this fancy Zoom magic that we do to make this happen every month. So thank you to Calendly for hosting and providing all that. During the event, if you take a look down in your little Zoom bar, there's a Q&A feature there. Use that to post your questions for the speaker. He says that go ahead and post them throughout. And what I will do is just rudely interject into his speech and interrupt him and read your question out loud, and that'll get answered during the presentation. And then as well, make sure to kind of stick around until the end of the event. We like to do a social hour kind of afterwards where we'll let everybody kind of get on camera and on mic and chat a little bit and try to replicate that more fun part of the meetup experience. Let's see, I don't see anything in chat. Oh, looks like we have one in Q&A for a role. Hold on, give me a minute to pull this up and see what it is. Doing it live here. Jeff, do you want to drop details in the chat? Oh, chat is disabled. Okay, I can fix that. It looks like this one is for Capital One Careers is hiring a lead backend software engineer. Jeff Spar is our man to talk to here, so catch him after the meetup if you're interested in details, and I'll try to get his contact information to make sure that makes it into the show notes as well. And that's all I've got. I will get chat enabled in just a moment, folks. Sorry about that. Okay, with that, we're going to go ahead and dive in. So our presenter today is Jason Hall. He's a staff engineer at Chainguard, and he's going to be introducing us to Wolfi.
All right. Hi. Let me get my screen shared. Do you see this? All right, cool. Yeah, so I'm Jason. I'm here to talk about Wolfi. Like Alex said, if you have questions, feel free to save them to the end, but also feel free to just put them in the Q&A. He'll throw something at me and ask the question. I'm also told that I have no time limit, so I will talk for as long as I can about whatever you want. So feel free to ask, anything you want. Yeah, like I said, I'm Jason. That's my face. It looks like me. That's a better picture of me than this one. I am a staff engineer at Chainguard. I live in Brooklyn. I naturally love pizza. Feel free to talk to me about any of those topics, either in the Q&A right now or afterwards. We can chat about whatever you want. I work at Chainguard. Chainguard's mission is to make the software supply chain secured by default. The thesis is basically your code relies on a ton of code that you didn't write, even more than you think. Even taking into account the advice that your code relies on a lot of code, it's more than you think. That's libraries linked into your application, depended on by your application code, included in the container that your application is running on top of, included in all the containers in sidecars and other sort of things running in your clusters. Running Kubernetes itself is code that you probably did not write, that you rely on. Code that runs Kubernetes is code you did not write, that you rely on. Code that runs under the hypervisor, etc., all the way down to, like, BIOSes and various low-level things. I'm going to go out on a limb and assume you did not write every line of all of the code that is between your application and the hardware. If you did, good job, nice work. You might not benefit from this talk. But assuming that you did not write every line of code between you and the hardware, you're going to rely on a lot of code you didn't write, and a lot of that is scary, can be scary. So our goal at Chainguard is to make that a little less scary. We have a number of efforts going on to try to make that better. We engage a lot in the SBOM specification community so that we have better tools for knowing what that stuff is. Like you would be shocked to know how little we know about what all the code is that you depend on. Just cataloging it is like a huge effort. And so SBOMs are sort of our effort, or not only our effort, we contribute to the effort of SBOMs to do that. We contribute a lot to SigStore, which is a project, a number of systems and tools for securely keylessly signing things to sort of prove that this came from where you think it came from and was attested to by who you think it was. We have a product called Chainguard Enforce, which runs on your cluster or outside of the cluster and enforces policies. You can say containers images must be signed by these people, must have come from CI, must, et cetera, policy enforcement and distribution at scale. And Chainguard Images, which is the product that I work on, which are secure base images, which I'll talk about a little bit more later. And what powers secure base images is our secure Linux distro, Wolfi, which is what I'm actually here to talk about today. So probably going to toe the line between images and Wolfi, but start with images, go down into Wolfi, and come back up for air. All right. So yeah, what do I mean when I say a secure base image? Mainly, when you think of a base image, you think like, Alpine, Debian, Ubuntu, maybe Red Hat, UBI. I don't know. Name your base image here. That's a very clear, specific instance of code you didn't write that you depend on. That is very close to your application. That is in the container that is serving user requests, let's say. And so if there's something wonky in there, that could really mess up your day. So we want to provide a better, more secure base image. One of the things we do is we sign each and every image we produce. You can cryptographically prove that it came from our CI. You can go look at that CI run. You can find the logs for that CI run. You can see everything it did, everything it built into it. You can trace that all the way back to the commit of the source that produced that image. We also produce thorough and reliable build time SBOMs for every image. You can know exactly what's in that image. It's clear and easy to read, as SBOMs always are. And so then you can know exactly what vulnerabilities are in that image. So if another log4j hack comes out and says, log4j version 4.5.6 has this, critical CVE, you don't have to spend a week figuring out where log4j version 4.5.6 is running in your cluster. You can just say, hey, SBOMs, like, where am I vulnerable? And a big part of what we're going to talk about today is the third one, which is fast updates from upstream. So we don't write everything that goes into our containers either. We rely on upstream sources. We rely on, very, very many open source projects. And our job is to get those to you as fast as possible. The thesis here, the theory is that vulnerabilities are just inevitable. Like if you're writing code, you're writing bugs, and some of those bugs are going to be vulnerable to exploitation, and some of those are going to be critically vulnerable to exploitation. So avoiding that is really the only way to avoid this is to stop writing code, which if you can, by all means. But if you're writing code, it's going to be vulnerable. The only real solution is to patch these as quickly as possible. The good news is that when vulnerabilities come out, patches are actually pretty quickly available. Think about like, I'm going to pick on OpenSSL, but just because OpenSSL is a very critically important, high visibility project, not because they're bad, they're very good. But think if you're like a maintainer for OpenSSL, if there's a vulnerability, you want to patch that immediately. Like this is your project, this is your thing. You want to make it better as fast as possible. So in general, like if there's a critical vulnerability, there is a patch already available by the time that's disclosed. There is all, even for less high visibility projects, if there is a vulnerability, there is a patch for it as soon as there is a vulnerability discovered. So that's the good news. The good news is that patches are available pretty quickly from upstream. The bad news is that it can take some time once that patch is written to be agreed upon and code reviewed, and sort of, a bunch of people have to look at it and make sure that this doesn't have some performance regression, or like expose some other bug, or like, maybe while you're fixing that, you find some other CVE that is in the same area of code. So just the existence of that patch doesn't mean that it will be in a release. So that's the first sort of cause of slowness in getting this into your hands. The next one is, once that project like OpenSSL has a patch for this, if you depend on Debian, again, not to pick on Debian, replace this with the Linux distro of your choice. It takes some time for Debian to say this patch is good, and we would like to include it in Debian's OpenSSL or whatever. And then once Debian applies that patch, it takes some time for Docker Hub's Debian image to pick up that patch, to pick up that new release of that code. And then once it's on Docker Hub, it takes some time for your release cycle to pick up the new Debian. We can't really do anything about that fourth one. Like that one's on you. As soon as you can, try to update to a later version of things for your own security. But we can do a lot about the other ones. To solve this, to make this as fast as possible, we needed to have complete control over the supply chain. Like, just depending on Debian's release cycle and Docker Hub's release cycle was not going to cut it for us. So we started doing Wolfi, which is what I'm here to talk about. So Wolfi is, we call it an undistro. This is kind of marketing phrase that someone made up. But the reason it is an undistro, is because it doesn't have a kernel. We don't release a kernel with this. It's basically all of the parts of Linux without the Linux, and so we call it an undistro. So it expects to be run in a container. It expects the interaction with the OS and the hardware to be done by your container runtime. So it doesn't need a kernel itself. It's mainly purely a package ecosystem of packages that you can install. So like Alpine, it is APK based. You install APKs, you manage APKs, you request APKs. Unlike Alpine, it uses glibc to build everything instead of Muscle or Musel. I'm never sure I'm pronouncing it right. Muscle. I'm just going to commit to it. Jason, it's called Muscle.
It is Muscle, I think.
Okay, excellent. Just got to commit. People will believe you. All right. So it's APK based like Alpine, but it's glibc based, unlike Alpine. And every package is built from upstream source. So when you install, like, this is not unusual or different from other distros. Debian installs from upstream source, Alpine installs from upstream source, and so does Wolfi. So we update and rebuild and release when upstream repos release, like most distros, when we have a lot of automation to update as fast as possible. I'll talk about this in a couple more slides. And Wolfi is open source, obviously. Like, this is table stakes. I wouldn't expect you to rely on a Linux distro that we produce that isn't open source. But even more than that, I hope we are even more transparent than the average. We have a repo at wolfi.dev/os that is built on every change in GitHub Actions. You can see the logs, you can see the configs, you can see absolutely everything about it. We have an auditable build process with build logs accessible. And we have a documented, repeatable bootstrapping process. If you wanted to, from scratch, you could, in theory, if our docs are good enough, you could rebuild all of Wolfi from first principles up to where we are now, the same way we did, which I think is a real sort of improvement on the state of the art of reproducibility and transparency from scratch. I talked about some of the reason why we do this. The big one is that we can get fixes into the image as fast as possible. And that's a big one. Like, that's like the main big one, but there are some other ones that are worth exploring and digging into. A number of compilers have security adjacent build options. One of them is GCC has this fortify source option. So fortify source level 3, which is at least one better than Fortify source level 2. This option is not on by default and is not used, as far as I know, in any other distro. When built with GCC's Fortify source 3, binaries will detect buffer overflows and can mitigate a class of vulnerabilities. This is not the same as all your C code now becomes Rust. This is not the same as like you sprinkle Fortify source level 3 on it and now it's it's completely impervious to vulnerability, but it is a step, and Wolfi enables that step by default on every build. There's a link here from a Red Hat blog post about more of that and sort of some of the trade-offs, but mainly like, this is a good idea, we should do it. Another build flag that we enable by default is position independent executables. This tells the executable to load into random locations in memory every time it's executed. This also like makes a certain class of vulnerabilities harder to exploit and less dangerous when you do exploit it. This is another option that's off by default and on by default in Wolfi. And another example of where we make better security choices is, for instance, in curl. Curl has supported Rust TLS, which I prefer to pronounce Russells just because it's good. I don't know if they even call it Rust TLS, but I'm going to call it Russells. Curl has supported Russells since 2019. Russells is a Rust backend for TLS that is optional. Curl has a number of optional backends for TLS, and one of them is Russells, written in Rust. It has a better track record for memory safety. I don't know how to say this the least spicily, but Rust has a better track record for memory safety than other languages that shall not be named. And it's off by default in most distros, and it's on by default in Wolfi. So just by virtue of using curl that Wolfi built for you, you are taking advantage of Rust TLS Russells by default. You can get a Russells-less version of curl, but the default one you get from us is based on Rust. So that's the why we build from source, and I can go into more detail there too if anyone's curious. As for how we build from source, that's also sort of an interesting part of this. We've built a new tool called Melange, which is mainly a tool for easily building APK packages. Again, Wolfi is an APK-based distribution like Alpine. Melange is not specific to Wolfi. You can use it to produce Alpine-compatible APKs, just like you would with Alpine, but we use it in Wolfi. It's a YAML file because it's 2023. Everything's a YAML file now. And you define a set of steps, and those steps run in order. And at the end, the contents of the package are emitted outside of the build execution environment. Each of these steps are run in lightweight containers using bubble wrap. You can declare build time dependencies. Like, so this example is building kube control version 1.26.1, which I think is the latest one. This just says at build time, you need to have bash and build base and go. Build base provides like make and things like that. And the pipeline says fetch this tar gz from GitHub. Its expected SHA is this. If it isn't, it will break. And then run make kubectl. There's a couple other things cut out of here, but basically it's a very simple. I can show you the real actual one. It's a really simple build. And at the end of it, you get a package that includes a built kubectl. Packages are signed with Wolfi's keys. ARM builds execute on GKE clusters. We have other cross-compilation in Melange, or cross-compilation is provided by Melange using QEMU, if you're interested in other architectures. So yeah, Melange is open source and not specific to Wolfi. In this example, like I want to call out, like this is where we would put a patch to kubectl. If there was a critical vulnerability in kubectl that was not yet in a release, we could apply a patch after we fetch that source. If there was a build flag to make that was like make kubectl but extra secure, we could enable the but extra secure flag. These are options that are not available to us if we depend on other package ecosystems that aren't, ours, that we can completely control. And we can pass those benefits on to you. But that's only sort of half the story. That's how you build one package. We have a lot of packages to maintain. Right now, it's about 3,500 packages, and that's a drop in the bucket compared to Alpine and Debian and more mature, longer-lived distros. So we're investing a lot right now in automation of regular sort of release updates. Every time a new package releases, we want to have it available as soon as possible. We have automation in there to send a PR as soon as we detect that a new release is available. We have automation in there to say, watch the feed of new CVEs and say, oh, this package that we produce has a CVE, go fix it. Like, there's no automated solution to that yet, but like, notify someone, whoever is on call this week, goes and finds the patch and applies the patch and makes sure that it works. And automating of reporting of fixes, like, it doesn't really help if you just fix it. You also have to distribute the signal that it is fixed, so that downstream scanners like Gripe and Trivy and those things don't think that you are still vulnerable.
So
and then
Jason, quick question. What's the typical latency of just any given package? A new version being released in their repo and it being compiled and available through Wolfi?
It's hard to say in general. Like, the automation that we have is very good at detecting updates for GitHub-based projects. Like when there is a standard API to tell if there is a release, we have pretty good automation for it. There's some automation for other stuff using sort of other infrastructure that exists for detecting releases. And then some of it is unfortunately just sort of manual. Someone said that there's a release of this, let's go get it. I would say that this is an area of huge active development, is how we can sort of make this sustainable and automated so that it's less toilsome. But yeah, that's definitely something we're interested in, is minimizing that amount of time, especially for regular releases. Like, it should be relatively easy to tell if there is a new version of Jenkins released. We should be able to pick that up pretty quickly. And in fact, we do, but we'd like to expand that automation to more stuff.
Great.
Yeah, and security fixes is another one that's like sort of hard to say in the general. Like, sometimes you find out there's a CVE and there's a patch and you just like bump the version or like apply this clean patch. And sometimes it's not that easy and you have to do some work. But yeah, aside from that, we also have a lot of automation around just sort of making the repo, treating packages like cattle, right? We're not trying to have a bunch of cats roaming around. We're trying to like sort of steer a herd of packages around the savannah. I don't know, that's a weird analogy. And like I said, like, we're just getting started. This is small compared to existing other package ecosystems. So I think now is a good time to invest in this automation so that a year from now, we're not completely, drowning in the number of packages we have to keep up to date. We have a tool that we use that we wrote called Wolfi Control, Wolfi Cuddle, that is not sort of like intended to be used by anyone else, but we use it to keep packages up to date. And we run these inside of GitHub Actions and send PRs. This is an actual screenshot that I took earlier today of like a Jenkins release happened and a bot opened a PR for us. And I think all we had to do was like sort of eyeball it, make sure the build passed, thumbs up, and now we have the new Jenkins. This one's, I guess, open, so it's not quite done yet. But yeah, so that's Wolfi. I'm going to take a break here just to take a breath and sort of review. The point of Wolfi is we needed to get really fast upstream updates and security patches applied quickly. We wanted to take this opportunity to enable security options by default so that you don't have to care about them. We want to focus on automation and transparency and an auditable build process and reproducible builds. If you want to, from scratch, you can rebuild all of Wolfi and come up with the same result. So the question now is, how do I get it? What do I, hopefully I convinced you this is good and that you want to use it. How do you get it? There's a few options. One is, these are base images. You do with them like you do base images. We produce a number of base images. This one is Wolfi base is sort of our analogy to Alpine, which just includes the bare minimum number of packages and APK to go get your own packages. If you are using Alpine, you can do APK add curl get Python Ruby. On Wolfi, you can do curl or run, APK add curl get Python Ruby. I don't know what this is a weird build example, because what are you doing with Git and Python and Ruby? But I'm not here to judge. There's some natural caveats. This is a very, very simplified example. If you were migrating from Debian to this, you would have to switch to use APK instead of apt, and the flags are different. If you're migrating from Alpine to Wolfi, this is also, like I said, a change from muscle libc to glibc. That might be a good thing. I don't know. Or at least it might be a transparent thing and you don't care. That would be excellent too. Some of the packages have different names. Like even in this example, our Ruby is called Ruby 3.1 or Ruby 3.2 because we maintain both. Whatever, small minor changes are expected when you do this kind of change. But in general, if you are interested in trying out Wolfi, you should be able to replace your froms with our froms, and mostly it should work. Option 2 is you can use this other tool we build and maintain called apko. Apko is, I guess here's where it gets spicy. So us nerds at Chainguard, myself, I won't paint a broad brush. Me personally, I have not been very impressed with the security guarantees provided by Docker files and Docker build. I don't think they're very good for usability. They're okay for usability, but bad for security, and sort of not where I would make that trade-off. And I think apko is a really good alternative to Docker files if you're willing to take the plunge. apko is, again, not unique to Wolfi, not unique to Chainguard. You can use apko to produce images based on Alpine APKs if you want. But basically, its job is to take a list of APKs and stuff them in an image and push it to a registry. It doesn't require a Docker daemon. It's literally just fancy HTTP, tar, HTTP interactions. Like that, there's very little else besides those things. It's really, really good for building distroless images. If you want, I can go on a huge long rant about how great distroless images are. If anyone disagrees, I'm happy to make you see the light. But basically, distroless images are, the word is hard to define, but basically I think of it as there is not a package manager. When you get a distroless image, you have no way to add more packages to your image. apko is a really good option for building a distroless image. You just say, I want curl, get Python and Ruby. It doesn't even have APK in it. It doesn't have anything else in it. It has whatever is needed by those 4 packages and nothing else.
So Jason, this is my first job doing infrastructure, right? If I'm a new engineer, not me literally, I'm putting a bit. Why is it a good idea to not be able to add new things to my image? Why would I not want to have a package? But it seems like it's inconvenient, right? Like it's actually hurting me. Why is that a good thing?
Well, it is inconvenient, but you see, it's inconvenient to the person who might be attacking you. If I'm able to get a shell on your application as a bad guy, I'd love to APK add crypto miner or curl crypto miner.exe. But if curl's not in there, then I can't. Or if an APK isn't there, then I can't. Certainly, like, that doesn't mean that they literally can't. People can put together, they can fetch a file off the internet with 2 toothpicks if they want. But like, it's basically about giving them as few tools as possible once they're there. It also has benefits in terms of image size. Images, download faster and start faster when there's less in them. Vulnerability scan noise, like if your image contains 1,000 packages, some of them are going to be vulnerable, and you're going to have to deal with a scan that says you have 10,000 vulnerabilities. Are you actually vulnerable to all of them? Who knows? But there's 10,000 of them, so you have no idea. If it's both about reducing your security attack surface and your noise. So that's my mini distroless rant. I'm more than happy to keep going. But apko is a really good tool for building distroless images. It's kind of a spiritual successor to the Google distroless project, which builds its images using Bazel and uses Debian packages as its source of packages. So the two main downsides, I think, of GCP distroless, Google's distroless, is if you want to add just one more package, you have to learn Bazel. Like you have to go figure out Bazel. And if anyone has written Bazel, that's kind of difficult. The other one is like you're dependent on Debian's package ecosystem. And like I said before, no shade to Debian, they clearly do great work. But you may not be in full control of the supply chain of those packages coming into your image. So apko is better, I think, because it's got a YAML API. You can, if you want to add Go to this, you just add -go, and now you have Go in there too. Every image that apko produces includes SBOMs by default. apko knows exactly what packages it put into the image, and it just says, hey, I put in curl version 123, git version 456, Python whatever version 789, and that goes straight into the SBOM. No fuss, no muss. Like I said before, apko is not Wolfi specific. You can use this with Alpine packages. Plenty of people do. The third option is, and I sort of previewed this before with the Dockerfile example. We pre-build a number of these images ourselves, and they're called the Chainguard Images. They're hosted on cgr.dev. These are images we produce. We rebuild nightly with apko. We make sure they have the latest patches from Wolfi. All of the image builds are also on GitHub Actions. You can see them. You can see their logs. You can see exactly what went into each of them. Each image is signed, has SBOMs. We do a vulnerability scan as soon as we build the image to show you when we produced it. This was how many vulnerabilities there were. And we build images for AMD 64 and ARM 64. These are not just base images. These examples here are sort of what you would consider base images: Python, Ruby, JRE, and Node. If you're using Docker Hub's Python image or Docker Hub's Ruby image or Docker Hub's Node image, you should be able to use these just as a simple swap in. But we also have build time images like Go and JDK, GCC, Bazel, other ones. We have CI images like kubectl and Git. If you need in your deployment pipeline, if you need to like kubectl apply something. It turns out there isn't like an official image for kubectl, so we made one that we think is pretty good. Same with Git, there isn't really like an official Git image, so we made one. And then aside from that, there's also all kinds of other images. There's like Nginx and etcd and HAProxy and Redis, Memcached and Postgres and MariaDB and a bunch of others. The link at the bottom, you can go see all of them. And if you don't see what you want there, let us know. Let's talk. Let's add it to Wolfi. Let's add it to a Chainguard image. I think I'm allowed to make a commercial statement. We also provide vulnerability patching SLAs and support for no longer supported upstream packages in exchange for money as part of commerce. But all of the ones listed here are fully free and available, and you can have them. They're great. Yeah. So that's Wolfi at a relatively high level and some info about Chainguard images. Try it out. See what's missing. See what doesn't work for you. We'd love to fix it. Build your own image if you want to using apko or Docker files. Like I said before, if you want to, you can add a package to Wolfi. I'd be happy to help with that as well. We have bi-weekly community meetings. I think there was not one today. There will be another one in 2 weeks. If you want to come and ask questions or sort of show off what you're doing, wolfi.dev/community has the info for that meeting. And yeah, I guess that's it. I haven't been watching the Q&A, so I don't know if there's any questions, but
there's none posted right now. I do have a question for you. If I'm I'm on an infrastructure team or maybe a security team, and I'm considering using Wolfi, what are the cases where it might be a bad idea? Is there a situation where it's the wrong choice for me, or is it always the right thing to do and everything else should fall by the wayside?
Well, you're never going to hear me say a definitive yes, because I've just been doing this too long. There are certainly cases where it may not be a good choice, or it may not be the perfect choice. In particular, I would say like the relative newness of our package list is probably something that would probably prevent folks from just jumping in day one. Like if you need a specific package and we don't have it, like we'll have to add it. Come tell us and we'll add it and we'll put it there. That being said, we do have like sort of the ones you would think of. Aside from that, I mean, I think if you are on Alpine today, you may not know that you are depending on muscle specifically. You may not be, right? You may just be doing things and it doesn't ever, the difference between muscle and glibc doesn't really matter to you. You're blissfully unaware, that's great. If that isn't the case, in particular, if that isn't the case and you don't know that that isn't the case, then migrating to Wolfi may be a breaking change for you. We're also happy to help sort of sort out what's happening there. We have some experts in the concept of muscle versus glibc that would be happy to help you with that. But that's another sort of like, you know, potential landmine area is you don't know you depend on the specific behavior of muscle on Alpine. Moving to Wolfi would be a unintentional breaking change.
Sure. We have a question in the chat, and I'll just read it out loud for the recording. Do you have a contribution path for folks to contribute updates to packages themselves, or is that something that should and is only handled by Chainguard folks themselves?
No, absolutely. If you see if either a missing package that you would like to try your hand at adding, or an update to a package, or a fix to a package, even just like a comment, you know, a typo in the whatever description, feel free to send a patch. There's no, you know, mainly Wolfi is an open source project mainly contributed to by Chainguard folks at this time, but we accept contributions from anyone. We've got a number of external contributors that we're perfectly happy to, you know, I think a couple of them are even maintainers on the repo. If you want to make a change, please do.
Awesome. Now, I'm kind of curious, there's a lot of things that Chainguard's making available here between these kind of base images, these secure base images, Wolfi for your whole package repository. If I'm just looking to kind of dip a toe in, where would you suggest I kind of get started? You know, there's a lot of options here. What would be my first low-hanging fruit?
I'm very biased being on the images team, but I think just trying out a Wolfi base image is a relatively easy, you know, an easy lift, right? It should be relatively, if you're based on Python today, try our Python and see what happens. In particular, like do a gripe scan on your current app and see how many of these things come from your base image, and then base it on us and see how many of the things come from us. I think you will be pleasantly surprised at the much lower number. But again, I'm biased. We have other products. I could talk about Enforce if you want. That's a bit more of a product pitch. But if you're interested in sort of, I think that the nice overlap we have is that Enforce is a good way to enforce at runtime that you are using these things at build time. So like you can say, don't let me run something that has a critical CVE. Don't let me deploy something that has a critical CVE.
And is that run as a validating webhook in Kubernetes? Is that the idea?
Yeah. So obviously, in order to get that information, you have to have like the build time information to say that there is not, you know, what's in this image. Are there CVEs, things like that. So that's sort of a nice, to use a PM word, synergy between the images and Enforce product. But yeah, I would say the easiest like thing to do to get started is pick an image, find the equivalent from, try it out, see how it goes.
Awesome. One last question, and folks, feel free if you have a question that I'm not posing here, feel free to throw it in the chat or the Q&A. But one more question from me. Say I'm at a kind of a large traditional organization, you know, we're maybe running this cool new Kubernetes thing, but we're not all in on kind of the open source ecosystem. But I'm interested in having a more secure environment, and I'm interested in Wolfi. I'm interested in maybe using Chainguard's base images. How do I convince my security org to implement this?
Yeah, I think I touched on this a bit earlier. It's partially about, I think the way to convince people is to say, like, look at all these CVE results in Trivy, in Gripe. And not necessarily just to scare you into like, the application has 1,000 vulnerabilities, you know, like if you want to go scare the suits with that, that's great. But you and I as engineers know that like, that doesn't mean there are 1,000, like, it's not like 1,000 actual bad things. So part of the problem is that one of them is probably going to be bad, but which one? Like, you have 1,000 of them, and tomorrow there will be 1,004. Are any of those 4 ones bad? Who knows? The day after it'll be 1,011. So it's sort of more about like, wouldn't you like that number to be both lower and better signal? Wouldn't you like to know that it goes from 0 to 1 and then back to 0? As opposed to, I don't know, at some point you just sort of become a nihilist about it. And you're like, yeah, there's 1,000 vulnerabilities, probably, fuck it, whatever. I don't, you know, like, there's no way to fix it.
None of us would ever do that.
No, I certainly
Surely.
have not literally done that. I certainly would not. But hopefully when you did it, you felt bad about it. So in some way, I think like this is a solution or a possible way of getting from an uncountable number of CVEs to a countable number, and then a low number, and then 0. And that will not stay at 0, right? Like, there's going to be a vulnerability. Like I said, there's going to be something. It's better to go from 0 to 1 and back to 0 than to go from 1,000 to 1,011 to 1,009. Who knows what just happened? I think that's my main advice for sort of selling this to folks that may not be in the trenches.
Awesome, great. Last call for questions, folks. Anybody have anything? Any of our panelists want to pitch a question? Feel free to jump off mute and toss it out there. Otherwise, folks, post them in Q&A and chat. Last chance.
Yeah, I was a little late. Sorry if I missed this. What operating systems, like root instance operating systems, are you seeing this most commonly deployed with? And does that matter at all? I've seen things like AppArmor profiles interfere with things at times, and other, potentially like SE Linux, things like that. Is that something that you have observed and handle it all with Wolfi, or is that handleable with Wolfi?
I think to your first question, like, this assumes it is running in a container on top of a container runtime. So whatever is under there is hopefully the next part of my question, the next part of my answer will address the hopefully, but hopefully will not have to care about whether it's running, whatever the sort of lower level OS is. The second part, addressing the hopefully, is obviously hope is not a strategy. I have not personally seen issues with SE Linux or AppArmor. That doesn't mean that they don't exist or won't exist. I would say if you do, that would be a great signal for us to be able to go address those and hopefully fix those and pave the road for other folks in the future. We use this extensively in our own production services running on Kubernetes, and have had no issues for, I don't know, basically the whole life of Wolfi. As soon as we could, we got on our own base images and haven't had any issues with them. But yeah, if you hear anything about that, please let us know. We'd love to help debug that.
Yeah, I've mostly only seen some things with like running Firefox or Chrome inside of containers, and then those having some like very specific AppArmor things going on with them. But that's that's not obviously something that is Chrome not built to run in a container typically. So
yeah, both of those seem like they would cause real trouble, right? Like, they seem like real troublemakers in the space. But yeah, and that's not to say that like it should be impossible to run Chrome in this either, but that's sort of not what we're mainly focused on supporting. But if you do that, that'd be awesome. If you get Chrome packaged for Wolfi, I would definitely buy you a beer.
Hold my mate.
That's documented, folks. You're going to be held to it. Um,
Oh, we're recording. That's
Okay.
right.
yeah. All right. I haven't seen any other questions come in, so that may be. It looks like that's it for us.
Are y'all, Jason, are y'all also like trying to, go swap out like your image in place of other images in like the CNCF ecosystem? Like, for example, or are you hoping that that's like, community driven, people like this and they start moving?
Yeah, that's a good question. I would say it's not like a concerted effort that we are undertaking. I think we would, welcome the community doing that themselves. And as a member of the community, I will occasionally from time to time notice that a project is using, a particular Debian version or a particular old Alpine or something, and I will send a PR and see if they're interested in switching to an Alpine, or sorry, to a Wolfi base image. But it's not like sort of, our intention is not to hire people to go and pave the CNCF with Wolfi images. But if folks are interested in it, I mean, yeah, I would say the best I did, the closest I get to that is just sort of like evangelizing, like, hey, your image has 1,000 vulnerabilities. That's a shame. By accepting this one-line PR, you can get down to 0.
Yeah, it's a fine line to walk, but like all of our lives would be better if there was more adoption of it. Yeah,
I can tell you the thing we're not doing. We're not sending 1,000 automated PRs to every project. Like that's not, nobody wants that. Nobody, me, myself, and I do not want that. But when I stumble across a project that's especially using an old version, especially using something that has a lot of vulnerabilities, like, hey, this is a good candidate for a Chainguard image. You should try it out. But yeah, no sort of concerted effort to do that.
So not pushing it, but also not pushing it.
Not pushing it, but not pushing it. Yeah.
All right, folks. Anything else? Last call. Okay. I think that that covers us. I don't know how to force your screen share to stop. There you go. You got it. So I don't need to. Okay, folks. Well, that is actually it for us today. Thank you very much to Jason. Our itinerary is leaner than your development methodology today. So I think we're going to cut from here to social time in just a moment. As always, we're looking for speakers. If you're interested, reach out to us on Tech404, on the Kubernetes Meetup, or the Kubernetes Slack through meetup.com. We're always happy to have people come speak, both locals and esteemed members of the community, like our friend Jason here. And other than that, folks, thanks for coming.
Thanks for having me. See ya.